three, four.
Hello viewers, these are the components of a solar power system. As you can see, we have the solar panel. This is our solar panel, a monocrystalline solar panel. It is a 250 watt solar panel. We have the inverter. This is a hybrid inverter. We have the modified sine wave inverter. We have the transformer based inverter. We also have the battery. This is a 100 amps battery. This is a 200 amps battery. And we have the charge controller. It is a 60 amps PWM charge controller. Today I'll explain to you how these components are connected together to convert the energy from the sun to electrical energy. We start with the solar panel. This is where all the magic of a solar power system starts from. Once it is exposed to the sun, the solar panel starts generating current and voltage in the form of DC, that's direct current. The solar panel converts the sun's energy into electrical energy. Once the energy is generated by the solar panel, it moves from the solar panel to this device called the charge controller. This is a PWM charge controller. We have the MPPT, that is maximum power point tracking controller. Then PWM stands for pulse width modulation. The MPPT charge controller is more rugged and more efficient than the PWM charge controller. The MPPT is also more expensive than the PWM charge controller. Now, the function of the charge controller is to safely charge the battery. It is a charger. It charges the battery. It controls what goes into the battery from the solar panel so that the battery will not be over discharged or overcharged. So that is the function of this component. The absence of this component will lead to a shorter lifespan of the battery, because anything the panel generates, that's what it will receive. The battery will receive, which is not good and safe for the battery. Now we have the battery. This is a 12 volts 100 amps battery. Then the one down is 12 volts 200 amps battery. The function of the battery is for backup. The energy that is generated by the solar panel moves to the charge controller down to the battery. So the battery serves like a reservoir. Since the sun is not always available, it's not always there for us to harness, there is need for a device, a storage device, something that will store the current, a reservoir that when the panel generates, the reservoir will store this power, store this energy, so that whenever we need the energy, you just go there, and tap from it. So it's just like your overhead tank, that way you pump water and store. When you need the water, it's just for you to open your tap and the water will start flowing. That is the function of this battery. So there are different types of battery. We have the lithium battery, we have the flooded battery. This one is a sealed battery. Call it sealed or maintenance free battery. In the course of this training, we'll tell you their differences and show you how to connect or install all of them. Now the next component is the inverter. This is What the inverter does, this device, is that it converts DC to AC. So what is stored in the battery is DC, but once it enters this inverter and comes out, what the output you have is AC, which you now use to power your AC appliances. Now we have the hybrid inverter. This is a hybrid inverter. The one you can see here is a hybrid inverter. You can see there, hybrid inverter. It has an inbuilt charge controller. So with this hybrid inverter, you don't need this external charger. You don't need this external charge controller. Everything is inbuilt. Well, this is a 3 kVA 24 volts inverter with an inbuilt MPPT charge controller. You can see it from the nameplates, all the specifications. You can see the rated power is 3000 VA, 2000/2400 watts. You have the DC input 24 volts. That's what comes out from the battery. The minimum requirement of battery voltage that is needed to start up the inverter is 24. How you can interpret it and use it to design your system. Then we have, this is a bigger inverter. You can see it. This one is a transformer inverter. It's a 5 kVA 48 volts inverter. So for this one to start, you will need 4 of 12 volts batteries. You connect them in series to give you 48 volts before this inverter will come up. So also in the course of this training, we'll show you how to connect batteries in series and in parallel, connect solar panels in series and in parallel, depending on the size of your solar system, depending on the configuration, depending on what you want. If you want a 24 volt system, a 12 volt system, a 48 volt system, we'll show you how to connect the solar panels, connect the batteries to give you what you want. Now for the PWM charge controller, you can see what is written there. The maximum current is 60 amps. The rated voltage is 12, 24, 36 and 48 volts. It is automatic. So if you input a 12 if your battery voltage system is 12 volts, once you input it, the charge controller will automatically detect it. If it is 48 volt, it will do the same. Then if you look at this charge controller also, you discover that there are 6 terminals in the panels direct to that controller. You connect the pump, the solar pump, to the controller. Once the sun comes up, you see that the pump will start pumping. Then when the sun is not there again, it will shut down. It will not pump until the next day when the sun is available. So the essence of this battery, again, like I told us, is for backup, because we have different sunshine hours. Like in Nigeria, in northern Nigeria, the sunshine hours in northern Nigeria is higher than the sunshine hours. It's more than the sunshine hours we have in southern Nigeria. So you keep the battery as a backup, so that whenever you have that sun, it will just generate the energy and store for you in the battery, so that you can use, since it is not there 24 hours a day for us to harness. So that is the major function of the battery. So any system that has a battery, we call them battery based systems. There are other systems that are called grid systems. That is, they function with the power from the grid and with the solar panels. So once the sun is not there, if there's power from the grid, they do an automatic switch. If there's no power from the grid, they switch over to solar. So is we are going to show you how to I'm going to show you how to do all those things, how to size your system. A solar system, design a solar system, install it, and also maintain it. We also have other components like the cable. We use the cable to link all the components together, connect the cable from the panel, positive and negative, that's the black and red, connect it from the panel to the charge controller, from the charge controller to the battery, from the battery to the inverter, even from the inverter to your DB, your distribution box. So cables are used to link all these components together. There are different sizes of cable. This one is a 2-core. It's a 2-core 10 mm cable. This one is a 16 mm cable. Then the size of the cable depends on the size of your system, and of course the size of your system will determine the amount of current that is coming out of the system, the amount of current that the panel is generating, the amount of current that will be leaving the battery to the inverter once you put it on. So all those things will determine the size of the cable. I will also show you how to know the size or calculate the size of cable that uh, will be okay for the system you want to design. Because most times if the cable is not okay, at times the cable may burn, at times the system will not be functioning well, the inverter may trip off, a lot of things, the system will not be efficient. Then we have another one. This is a breaker. You can see this is a DC breaker. This is a breaker. From your between the charge controller and the panel, you need a breaker. Between the charge controller and the battery, you also need a breaker. Between the battery and the inverter, you need a breaker. From the inverter to your DB, you need a breaker. We also have other protective devices like the thunder arrestor, the surge protective devices. We have other devices that are used to manage the system, the BMS, battery management system. So like I told you earlier, in the course of this training, I will show you how all these things are being put together to convert the sun's energy into electrical energy in an efficient way. Failure to know how to size these things will not give you an efficient system. When you install the system, you begin to have issues. So do well to subscribe to my channel so that you will learn more and also you'll be trained on how to install and maintain a solar power system.